Hello and welcome to another one of these ADD videos. Today we're going to be looking at KAs and pKas and analogously understanding KBs and pKbs. So what happens whenever I have an acid placed in a solution of liquid water? Well, it's going to ionize into the two respective parts, one being the conjugate base. These two are going to be your conjugate acid-base pair, and then we're going to have the proton donated in the solution. And if we remember, this concentration of the liquid doesn't really apply because it's a fixed concentration. And if we were to multiply it on this side, we could redub this equation the acid dissociation, or the acid ionization constant. Okay, so basically your Ka will always be the concentration of the hydronium or the proton's conjugate base over the acid at equilibrium. So there is a proportional strength relationship between acid strength and Ka. This is simple for proportional to, and that means as one goes up, the other one goes up, and vice versa. Then there's also something called the pKa. If you take the negative log of the Ka, you get the pKa. It's also an index, but these are inversely proportional. So acid strength is proportion to the inverse of the pK. So that means as one goes up, the other one will go down, and vice versa. Okay? So you should also know that the two pKa's, pKa plus pKb, should add up to 14 at 25 degrees Celsius. And another thing you should know is that the strong acids will dissociate completely. So what that will mean is that this is also for strong bases. The HCl concentration, for instance, will equal the proton concentration because it's a strong acid. It'll dissociate 100%, or ionize 100%, however you want to look at it. Or let's say we had potassium hydroxide. All hydroxides are strong bases. Go ahead and memorize your strong bases. There should be a table in your Gen Chem book that lists both your strong bases and your strong acids. Be a good idea to memorize those. Again, KOH is a strong base, so we have 100% dissociation. That's basically it for this concept. There's going to be some calculations associated with KAs. Those are going to be a little bit more involved. They'll have your Rice table that we went over in the equilibrium chapter. Also remember that if the Ka is 10 to the negative 5 or less, that means when you have your equilibrium line of initial concentration minus x, this minus x will be negligible, and you can just stick with it. Now you'll have Ka equals x squared over some number minus x. That x is so small compared to the number that it doesn't affect the problem, so you can drop it. Alright? But make sure you go through the individual example videos for the different scenarios associated with KAs calculating Ka. So we'll be looking at, what's the pH, or what's the pKa or Ka at certain values, and you should be able to interchange pretty easily. So watch example video, practice, practice, practice. Thank you and have a nice day.